Welcome back to another video on my channel, math_exe. Today we're going to look at some example problems of number patterns and sequences. And if you want to learn how to find the answer of a specific sequence, you can check out some other videos. I have posted videos about how to find the answer of a arithmetic, geometric, and quadratic sequence. So I'll let you guys check out on that. Anyways, question 1. The formula for the answer of a sequence is as follows. So we have Tn is equal to 3n times n minus 1. So part A is pretty simple. We need to find the first 4 terms of the sequence. So with this, we can just find T1, T2, T3, and T4. For T1, you can just substitute n equals 1. So we have 3 times 1 times 1 minus 1, which is just 0 overall. T2, substituting n equals 2, we have 3 times 2 times 2 minus 1. This will be 6. And substituting n equals 3 for T3, this will be equal to 3 times 3 times 3 minus 1. This will be equal to 18. And then for n equals 4 for T4, you'll get T3 times 4 minus 1, which will be equal to 36. Alright, so that's it for part A. For part B, given the first 4 terms of another sequence are 2, 8, 20, and 38 respectively, and then we know the formula for the nth term of this sequence can be written as a quadratic expression. So we have T of n for the sequence given in B is an squared plus bn plus c, where a, b, and c are integers. And we need to find a plus b plus c, and then for part 2 in part B, we need to find the 10th term of the sequence given in B. So let's start with part 1 in part B. So let's just compare the first 4 terms of the sequence of the first given sequence, the sequence given in A, and the sequence given in B, which the first 4 terms are given 2, 8, 20, and 20. And I'll let you guys try to find a relationship between each term in the sequences. I'll give you 10 seconds for this. Alright, if you haven't discovered the pattern already, notice that each term in this sequence, the first sequence given in A, part A, to get the sequence given in part B, you just add each term by 2. So from 0, you add 2 to get 2. From 6, you add 2 to get 8. From 18, you add 20. And therefore, with this pattern, we can conclude that the nth term, and I'm referring the nth term as of the sequence in part B, this will be equal to the formula of the sequence in part A, but just added by 2. So we have 3n times n minus 1, and then we add 2 on the end. And perhaps we can expand this a bit. So let's see what we have. So we have 3n times n, which is n squared, minus 3n plus 2. And from the given question, we have set this in to be equal to this expression right here. By suiting terms and coefficients, we get that first a is equal to 3, b is equal to negative 3, and c is equal to 2. and therefore a plus b plus c must be equal to 2. And for part 2 of part B, we need to find the times term of the sequence referring to the sequence in B, given this formula right here. So for the times term, we can just substitute n equals 10. So we have 3 times 10 squared minus 3 times 10 plus 2. And then let's see what we have. So we have 300 minus 30 plus 2, which will be 272 overall. So this is our final answer for part 2 of part B. And that finishes the question. And let's jump into another question. Interesting. So the formula for the x term in the geometric sequence is, I'll just rewrite that, t of n is equal to 2 times 3 to the n. And we need to find and write the first 3 terms of the sequence. So for part A, that is pretty simple. The first term would just be 2 times 3 to the 1, which will be 6. T2 will be 2 times 3 to this 2, this will be 18, and then finally T3 will be just 2 times 3 to the 3, or it will be just 54. And then for B, find the ratio of any 2 consecutive terms of the sequence. So if you notice the pattern of the first 3 terms that I just written, 6, 8, and 54, and what I mean by ratio is the number that you are multiplying or dividing to get the next term. So in this case, the ratio is pretty simple. The ratio is noticeably 3, because you multiply by 3 to get the next term. So for B, the ratio is 3. And for C, find the value of A if the 8th term is 1458. So we can just set up an equation. T of A is equal to 1458. And using our given formula right here, except we're using A as a variable. So 2 times 3 to the A is equal to 1458. Dividing 2 on both sides, leaving us with 3 to the A, this will be equal to 729. Yep. And you can just probably do some logarithm right here, or possibly noting that 729 can be written as 3 to the 6, and therefore by knowing that this is also equal to 3 to the A, and therefore A must be equal to 6. That's it for the second question, and let's get then to the final question. Right, for the last question, we need to observe this following pattern. So for line 1, it says that 1 squared plus 1 plus 2 is equal to 2 squared. For line 2, 2 squared plus 2 plus 3 is 3 squared. Line 3, 3 squared plus 3 plus 4 is 4 squared, and so on. And you can probably see the pattern already right here. So first we need to write line 6. So with this pattern, we can wait a second. We can rewrite line 6 as follows by noticing a pattern right here. Notice this one corresponds to this one and this one. This 2 corresponds with this 2 and this 2. This 3 corresponds to this 3 and this 3. And therefore later on, I'll just write the scribble right here. Line 6 will correspond to 6 squared plus 6. And that plus something is, we can just rewrite 2 as 1 plus 1. We can rewrite 3 as 2 plus 2. And you see later why. You can rewrite 4 as 3 plus 1. And notice each number corresponds to their own line. So if 1 corresponds to this one, this 2 corresponds with this 2, this 3 corresponds with this 3, and then yeah, you can just follow the pattern right there. And therefore this will correspond to 6 plus 1, and it will be correspondent into 6 plus 1 squared. Since we know these numbers are equal, therefore they must correspond to the same expression. And therefore we can just rewrite line 6 as 6 squared plus 6 plus 6 plus 1 before, we can just simplify into 7, and this will be equal to 7 squared. This is for part 1. And part 2 is pretty interesting. Need to generate a quote-unquote formula, because it's not really a formula you would see, but it actually helps us to generate more values of each line in this pattern. And then we need to prove each line holds true algebraically. So this is just like a mini proof type of question. So since we know the corresponding numbers into like the orders, since we know this one corresponds with this one and this one, we can rewrite line n as something like this. So we have line n is corresponding to n squared plus n plus a number after n, which is just n plus 1, and this will be equal to n plus 1. And then proving this isn't that difficult, so we can just simplify the left hand expression. So we have n squared plus, we can just combine those n's. We have 2n plus 1 is equal to n plus 1 squared. And notice this factors as a perfect square. This will be equal to n plus 1 squared, and therefore we maintain the equality, and therefore just put a box right here. Alright, so for part B, I would say is another interesting problem. So given line A as in the pattern, so we have line A as q squared plus q plus r is equal to 100 squared. And then from this we need to find A, Q, and R. So let's just rewrite the line first. So we have line A, q squared plus q plus r equal to 100 squared. And using our quote-unquote formula for this, we know that this n corresponds to this n and this n. Therefore, A must be corresponding to this q and this q. And from this, we know that A must be equal to q. And then from this, we also know that this n plus 1 is a number above n, same as this r is a number above q. So we can just say that r is equal to q plus 1. And then finally, this n plus 1 corresponds to this n plus 1. And therefore, using that same trick, this r must be corresponding to this 100. And therefore, we have gotten our first value, r is equal to 100. Substituting each value r into this equation, we can get that this will be equal to 100 is equal to q plus 1. Therefore, q must be equal to 99. And then since A is equal to Q, this also equals to 99. So we have found its value of A, Q, and R. So if A is 99, Q is also 99, and then we have R is equal to 100. And that finishes this video. So hopefully you guys enjoyed this video. Please subscribe for more videos, and I'll see you guys in the next one. Goodbye.